Today we'll be creating this infinite looping pendulum animation in Blender 3.4. This is going to be more of a beginner Blender tutorial than the ones I've made before, so I've tried to go through every single step as best I can. If I've missed anything or if anything is unclear, please let me know in the comments. It'll help me make better videos in the future. The blend file corresponding to this tutorial will be located in a link in the description if you want to go ahead and grab that. And in this tutorial, I use a Blender setting to make the connections between nodes straight rather than the default curvy. The way that you set that is in Edit, Preferences, under Themes, go to Node Editor, and scroll down to Noodle Curving, and just set that to 0. So go ahead and open up Blender, click into your scene, press A to select all, X to delete, and then Shift A to add a new default cube. Then we'll be adding a Geometry Nodes modifier, creating a new Geometry Nodes network. We'll split our viewport by hovering over the top right, clicking and dragging to the left, and then change this to a Geometry Node Editor viewport. In this view, you can press N to hide the panel on the right. And now we'll jump into the nodes for creating the curve guide, which is going to drive the entire animation. To do that, we'll start by adding a curve primitive line. We're going to resample that curve to add some more points to it. In this case, we're going to want to resample by length so that it adds a point every 0.1 meters. So if you delete the original group input node and pipe that curve node into the group output, you'll see a curve here in the 3D viewport. We want it to be a horizontal line going from -y to y at 1. And next we'll want to offset the x position of this curve so that it creates a sine wave. To do that, we'll first need a position input node, a separate XYZ node to get the y component, because we'll want to perturb the position of x by the sine of y. So add in a math node, change that to a sine node, then pipe in y to its input, and then we will need a set position node to actually change the position of the points on the curve. And we will also need a combine XYZ node in order to create a vector where we're only changing the x component. So pipe the output of this sine function into the x input of this combine XYZ node, and now output into offset. And you'll see that this is actually following a sine curve. But in order to see it a little bit better, we'll have to multiply the value of y by a higher value. And as we bring that up, you can see that the sine curve starts to emerge. Another way we can do a similar process, if we control X to delete that multiply node, we can just change the length, and in this case, make the original curve line longer, and we will see the curve appear. So now that we have our sine curve, we'll want to change that into a looping animation. So if we add an add node in between the y component and the sine node, then as we move the value of the second input to the add node up and down, you'll see that the curve moves in the y direction. And so we'll want to animate this value using the scene time node. So just Shift A, you can hit search, and search for time. Select the scene time node, and we'll be using the frame output for this. Now if you just pipe that in there and you press space to play the animation, you'll see that it's moving way too quickly. And so we'll want to divide by a higher value in order to slow that down. So in this case, I'm putting a divide node in between the frame output and the add node, dividing by 120, and that's pretty slow. So if you change it to something like 32, then it moves a bit faster. But we want this animation to loop from the end to the beginning, and you'll see if I flip to the end of the animation, once it hits 250, which is the last frame, it'll jump back to 1, and it's not a seamless transition. And I'm going to show you how to make that seamless. So first you're going to want to choose how many frames you want your animation to actually be. In this case, we'll do 120 frames. And then this divide node will want to have the same value as the last frame of your animation. And so what that does is when you're at frame 120, the output of this value is 1, at 0 it's 0, and then we'll want to change that so when you're at 120, the output is 2 times pi. The way that you do that is you can multiply by pi. Just click into a field in Blender and type pi in order to get pi. And you can click it again and multiply by 2. And now when you press play, when it reaches the end of the animation, there'll be a perfect loop. So now you have a seamless sine curve looping animation, and this is going to be the base for everything else. So next we'll want to add another curve line that will act as the guide for the actual pendulum, which will swing back and forth and move with this guideline as it animates over time. So first let's do a little naming to keep everything clean. I'm going to double click on cube up here, type in guide. I'll change the name of this geometry nodes modifier to guide. I'll hover over that, press Ctrl C to copy, and paste that as well into the actual name of the modifier. Then in the 3D viewport, I'll hit Shift A, and I'll add in a new cube. This time, I'll name it Pendulum. I'll add a new geometry nodes modifier, delete the default input, and then add a curve line primitive. So we'll want the beginning of this line to start at the fulcrum of the pendulum and the end to just touch this guide curve. We can set the fulcrum to be wherever we want because that won't move, but we want to set the end position to sample from this curve. So what we'll need to do is bring in the information of that guide curve using an object info input node. We'll go ahead and select the guide object. We'll add in a sample index node. Bring the guide geometry into that. And then we'll want to sample the position of that curve. So we'll bring in a position input. We'll change the type of this sample index to vector because that's the type of the position that we're sampling. Pipe that into there. And then we'll set this index based off of the point on this curve we want the endpoint of our pendulum to be. So in this case, it won't be 0. And we'll figure out exactly what we want in a second. So if you just take the output of that sample index node, you pipe it into the end node, you'll see that the line is connected to the guide. So we want the sample index to be something near the center. So if we find that index is 50, we can see that the end is connected to the guide curve, and then we can move the fulcrum up. And now we have the beginnings of our pendulum. One thing you might notice is that as the animation progresses, the length of this pendulum line actually grows and shrinks. It's smallest at the center, largest at the edge. And that's not the behavior we want, because the line or the cord or the arm of a pendulum is not going to change length as it swings back and forth. So actually we need to change the z component of our guide curve to conform to a circular shape in this direction, so that as this curve swings, it stays the same length. So hopping back into our guide geometry nodes network, we'll want to create a new set position node, Shift D to duplicate that node, pop it in there, and then this time we'll be wanting to change the z component. So we'll use a new combine XYZ node, and then we're going to use some math nodes to create a circular offset for the z component to achieve our desired results. Yet again, we'll be needing a position input node as well as a separate XYZ node. So Shift click to select both of those, Shift D to duplicate, bring another copy of those over here. And since we know that the equation for a circle is x squared plus y squared equals radius squared, we can create some math nodes to figure out how to change the value of z to conform to a circle. So in our case, x is x, but y runs along the z-axis. So really, our equation is x squared plus z squared equals radius squared. And if we do a little math, we'll find that z equals the square root of the radius squared minus x squared. So we'll implement that with some math nodes. Go to Utilities, add in a math node. We'll start with a power node, and we'll take x and bring that to the power of 2. Then we want r squared minus x squared. So we'll Shift D to duplicate, change that to a subtract node. R squared is going to be our first value, which we'll just set as needed. And then we'll pipe in x squared to the second value. And then we'll want the square root of all of that. So Shift D again to duplicate, add in a square root node. Then we'll pipe that into our z component, and now we have a circular shape to our guide curve along the z-axis. But you'll notice that it's on the opposite side of the ground plane that we want. So we'll just add in one more math node, and we'll multiply by -1. So now if you go back into the Pendulum Geometry Nodes network and you change the start position to be 0, 0, 0, which is also the center of the circle that we calculated in the last step, then the length of the pendulum will stay the same. And going back to our Guide Geometry Nodes network, if you play with the radius of that circle, you will get less of a curve to your guide curve and a longer but consistent in length pendulum line. So now that we have the basics of our looping pendulum animation implemented, we can start to add some geometry to render out something that looks really cool. So to do that, we're going to be creating 2 new objects. One will be a pendulum geometry object, which will use this pendulum curve as a base, and the other will be a track object which will use the guide curve as a base. So go ahead and just press Shift A to add a new object. Double click to rename it. This will be the pendulum geometry object. Shift D to duplicate that. Double click on the name to create the track object. Go ahead and hide that one for now by clicking on the eyeball on the right. Then we'll select the pendulum geometry object, add a new geometry nodes modifier, hit new, and we'll name that pendulum geometry. Again, we can Control C over the field to copy it, and then hover and Control V to paste the name. So we'll want to bring in the pendulum curve object as an input. So you'll do an input object info node, delete the group input node, select pendulum geometry, and then we can see that we have that information in this network now. So first, let's create a weight mesh to put on the end of the pendulum arm. We'll do that with a mesh primitive icosphere node. And then what we'll want to do is we will want to sample the curve of the input geometry, get the position at the very end of the curve. So that's a factor of 1. 0 is at the beginning of the curve, 1 is at the end. And then we'll use a geometry transform node to set the position of this icosphere, which by default is at 0, 0, 0, to the position at the end of the curve. So if we just change the radius of the icosphere and up the subdivision levels, you can now see that this object is pulling from the end of the pendulum arm and moving along with the animation. But we actually want the bottom of this icosphere to just barely touch the edge of the guide curve. So the way we'll do that is we will add in another transform node, and we'll translate in the direction from the position of the icosphere to 0, 0, 0. In this case, you can use the position output that we used to set the position of the icosphere. So we'll add in a vector math node, and we'll want to use a normalize node so that this length of this position vector, which goes from this point at 0, 0, 0 to this point at the center of the icosphere, set that length to 1. We'll add that into the translation, and you'll see that it actually moves away. So we'll add in one more vector math node, this time a scale node, and we'll want this value to be negative the value of the radius of the icosphere. So then that way, however big this radius is, it's moving back towards the center of the pendulum by the same amount. So to make that a bit easier on us, if we want to change it in the future, we can add in a value input node. Let's set that to something like 0.2. We'll pipe that directly into the radius. And then we'll add a math node, which is just going to multiply that value by -1 to make it negative, and then put that into this vector scale node. So now if we change the radius of the icosphere, it stays in the correct position. Next, we'll need some geometry for the actual arm of the pendulum. So what we'll do is we'll just directly take the output of this pendulum object info input node. And we'll do a curve to mesh node. And we'll use a circular curve primitive as the profile curve. We'll definitely want to set the radius of that to something very small. Let's do 0.005. The resolution doesn't need to be high. Let's set that to something like 8. And then we'll add in a join geometry node to merge these two pieces of geometry together. And you can see now the pendulum has an arm. So now moving on to the track geometry, we'll go ahead and unhide that object, add a new geometry nodes modifier, add a new network. We'll name this track, Control C and Control V to copy and paste that name. We can delete the default group input, and then we will add in an object info node, and we'll want that to correspond to the guide object. And if we select the track object, we can see the guide geometry. One of the simpler tracks that we can create will use a curve to mesh node with a curve line primitive that will run from a negative x value to a positive x value, maybe a little bit smaller than that. And you can now see the pendulum moving across the surface of this track. At this point, it's just this thin strip. If we want to add some dimension to the track, we can actually add another modifier after the geometry nodes modifier. It's going to be this solidify modifier. Add a thickness of whatever you want. Let's say, I think the 0.1 is a good default. And then you can see how we've got this smooth shading, which is making it look a bit odd. One way that we can get rid of that is that we can add in a bevel modifier, which we'll want to use ultimately anyway, because it'll give a little bit of curve to the edge of our geometry. Set the amount to something really low, maybe 0.005, and that'll catch the light in our rendering and give you these nice sharp line edges. We'll put the segment amount up to, let's say, 8. Now we've got this nice curvy track that the pendulum follows. And with that, we can move on to setting up some materials, some lighting, and then rendering out our animation to make something really cool that we like. So let's start with some simple materials on the track. To apply a material to the track, we'll click in to the geometry nodes modifier, and then right before the group output node, we'll add in a set material node. We'll create a new material under the materials tab on the right here. Hit new. We'll rename this material to track. Actually, let's name it metal. I'm going to make it a metal. And then select that from the drop down in the set material node. Now if we want to edit that material, we can go into this top left drop down and switch to a shader editor. And we can see the shader nodes for the metal material in this viewport here. So first off, let's go into our rendering settings in this render properties tab. Let's change our render engine to cycles, or this is what I'm going to do. You can use Eevee if you'd like. And I'm going to change to GPU. If you've got one for rendering cycles, that's great because it'll render a lot faster. Then in my 3D viewport, I am going to turn off show overlays so I can just see the render. And before we get started on the track material, I just want to add a little bit of lighting in. I'll do that with Shift A, and I'll add a sunlight. So let's just start with a simple sunlight pointing in a bit of a direction. So I'll turn those show overlays back on. You can see the sunlight here. I'll press, by the way, if you want to snap into an orthographic view on any side, when you're navigating with the middle mouse button, so click down on that middle mouse button and drag to rotate. If you hold Alt, it'll sort of snap to one of these orthographic side, top, or bottom views. So in one of those views, or any other view, you can press R to rotate, and rotate the direction of that sun directional light. I'll just rotate it to the side there, and then I'll move to the top, and I'll rotate it a bit around the Z-axis as well. And that looks pretty good to me, just for some initial testing. I'm also going to turn off the lighting for the world, or make it black. So in this World Properties tab, just go to the color setting, drag that all the way down to 0 for the time being. I'll go ahead and click that Show Overlays toggle again. I'll select my track objects to get back to the material. And then I'm just going to create a really simple metal material by just taking this default principled BSDF shader, putting metallic all the way up to 1, and bringing roughness down to something like 0.15. One more setting in the bevel modifier that you want to set is under shading. You want to hit harden normals. And I'll get this little notification here that I need to enable auto smooth in order for this setting to work. That's in your object data properties tab under normals. Hit auto smooth. And what that does is, you can see on the edge here how it changes a bit. It hardens the edge. You can kind of see it happening there. It's subtle, but it's an important setting for a good render. So that's really it for the metal material. We're not going to do anything fancy there. So if we select the pendulum geometry, go into that geometry node editor, we will set a material for both the pendulum arm, which comes from this input to the join geometry node, as well as the pendulum weight, and there'll be different materials. So we'll use two set material nodes, one that goes here, one that goes here. The arm will just be the same metal material as the track, which will become more visible when we change the lighting in a later stage. And we'll add a new material, as we did before, for the weight. And this is going to be a glass material. One more thing we'll want to do for the weight is we want it to be shaded smooth, so that we don't see all these individual faces of the icosphere. I am going to bump up the subdivisions one more level to level 4, and then if you Shift A, hit search for smooth, you can put in a set shade smooth node that will change that object to smooth shading. So jumping into the shader editor, we will delete using X the principled BSDF node, Shift A to add a new shader. Let's add a glass BSDF, and then pipe that into the surface. We're going to want to change the lighting a bit now in order to see this material a bit more. The way I'll do that is I'll switch to the world shader type. You can do that with this drop down up here in the shader editor. So this is the nodes for the world material that we edited before in this panel on the right. So what I'm going to do here is I'm actually going to add in lighting that has a gradation from black to white, where the top of the world sphere is just white and then it sort of fades out to black at a certain interval. This is a really useful lighting setup for a lot of different scenarios, and it's super, super simple. And so first you just add in a geometry input. We're going to use this position output. We'll use a separate XYZ node, and we're interested in this Z component. So if I pipe that Z component straight into the background color, immediately you have a pretty good effect where it's sort of like white up there and everything below the horizon is black. And we can actually just go with this straight up for now. What I will do is add in a math node with a clamp value just to make sure that we're not getting negative values, because you can see when I have it off, this black is really black. If I hit clamp, it brightens up a bit, and that's because the dark values in the bottom are actually negative values, and so that will mess with your rendering a little bit. And you can actually just use this add node to edit where the horizon line starts a bit. So I'll put it a bit up higher using a negative value. Nothing too crazy. I like something like that. I want to show you one more cool shader trick for the actual pendulum weight. So if we change the shader editor back to object, we've got this really simple glass shader. And what I'm going to do is I'm going to add 3 glass shaders, and they're going to have 3 different colors. One is just full red, the other is just full green, the other is just full blue, and we're going to create this sort of like fake chromatic aberration effect in a really, really simple way. So start by just setting your colors accordingly. Just click on that color, switch to RGB mode, and then for this first one you just want full red, 100. For the next one you want full green, which is 010, and for the last one full blue, 001. Then we want to add all of these shaders together using an add shader node. So first we'll add the red and the green, and then we'll add the output of that to the blue. And now you really just have the same shader as before, just like white glass, but you can see that there's some color in here as the rays aren't fully converged. So I'm actually going to set my viewport samples to 0 so that there's no limit, so this will sort of just run. And what I'm going to do to make the slight chromatic aberration effect more apparent is I'm going to slightly perturb the index of refraction for both the red glass shader and the blue one. And so I'm just going to add a little bit to this one and subtract a little bit from this one. So if I just kind of do that manually, you can kind of see you'll start to get this cool looking RGB effect. But I want it to be really uniform, so I'm going to use some math nodes. So if I add in this math node and an input node, a value input node, so this will be our base index of refraction. I'm actually going to set that to be 1.52. And then I'm going to add just a little bit to that for the index of refraction for my red shader, and I'm going to subtract just a little bit for my blue. And I can add in another value node and pipe that into these to just be able to easily control the size of that offset. So the higher I go, the crazier it gets. You want to keep a pretty low value. 0.1 is still pretty high, so maybe it's something like 0.025. That looks like a pretty good value to me. We'll be playing with lighting a bit more, but at this point it's good to set up your camera and get some of your rendering settings squared away. So I'm going to hold Z and then hover over solid to switch back to solid mode. And then I'll add a camera to my scene. I'm going to turn the overlays back on so I can see the previews. With my camera selected, I'll hit Alt-R to cancel any rotations that the camera started out with. And then I'm just going to move it using G. I'm going to click G and then grab the camera and then just move with my mouse. Left click to confirm. Hit R to rotate it kind of towards my pendulum. And then I'll press 0 on the numpad to view the world through the camera that I've just created. So now you can kind of see the animation from the perspective of the camera. I'm going to change the camera settings for this camera from perspective to orthographic. And we're going to render out a square. So let's do 1920 by 1920 in our rendering settings. Over here are output format settings. You can just click and drag on both those values, and when you let go, you can change both at the same time. Type it in, press enter. Then I'll change my orthographic size to zoom in just a bit, maybe a bit more than that. And there you go. This is the beginnings of our final output. I don't actually want to see the render outside of this view. So first, I'm going to go into my Output Properties tab, and I'm going to click on Render Region so it actually doesn't render in the viewport outside of that. And then as well, I'll go into my camera settings, and then under Viewport Display, I'll bring this passive part out. I don't think I've ever said that right in my head. For my entire Blender life, I've been saying pass or pout. Pass part out, whatever. Set it to 1, then it's all black around the viewport. Now going back to my rendering settings, I actually am going to set a max number of samples. I'll set that to 512. I'll do the same for rendering. I'll turn off noise threshold for both because I like to just do a maximum number of samples. And I'll turn on viewport denoising. And I'll change that to optics for the viewport because it's a bit faster. But for a final render, we will use open image denoise. I'm actually going to turn off denoise. All right. So now for a little bit of lighting, we're going to use a pretty simple setup. I'm going to create a couple of different suns, which are just directional lights, to highlight some of the edges of the track and get a little bit more revealing towards the geometry that we've created. So I'm going to keep this view as my rendered camera view. I'm going to change the mode of this viewport to a 3D viewport as well, so that I can duplicate the sun using Shift D and then rotate that. I'm just going to light that from the back there, and I just want to highlight that nice crisp beveled edge. Doesn't need to be quite so bright though. So I'll bring the strength value down to 0.1, and maybe I'll rotate it a little bit more in this direction. No, you know what? I liked it the way it was. So I'm going to duplicate that sun one more time, and then I'll rotate it in the opposite direction so we can highlight that bottom edge coming from the other side as well. So that's looking pretty good. Maybe I can duplicate the sun just one more time. Oh, actually, you know what I'm gonna do? I want to change the angle for these two accent suns. So I'm gonna hit Alt to change both at the same time. I'm just gonna drag that up to a much higher value. So now you can see the angle is basically how soft the shadows the sun will create are, or the size of the sun, the virtual sun, in the sky, as it were. So the higher the angle, the larger it is, and so you'll get these reflections like down here that you'll see, or these illuminations that you won't get if you just have this tiny little point in the sky. So let's make that a bit bigger, and you'll get these nice little highlights. And I'm starting to like the way that looks. Let's make it a little bit bigger. It's all up to you and your artistic vision. Speaking of artistic vision, I think I want to change the angle of the camera a bit so that you can see more of the track. Keeping that pendulum near the center. So just G to move, R to rotate with that camera selected. And I'm doing it from this side orthographic view. Another way you can get to that is just by clicking on this gizmo up top. So if I click on that X, I'm in the side view. And I think I like that quite a bit better. So I'm going to keep it. Very nice. So another thing that you can do to make this animation a little bit more interesting and also make it your own is you can change the shape of this pendulum weight. And one way to do that is by creating your own object, which you can model in any way you want, and then bring that object info node into the pendulum geometry network and replacing the icosphere with that. So what I can do there is, instead of using this icosphere, I'll unhook that for now. And then I will add a new object info node. I can just duplicate that one with Shift D. And then in my 3D viewport, I'll create a new object. Let's just make a cube for now, just for fun. And let's call this the weight. Go back into my geometry node editor, click on pendulum geometry. Then I will select the weight object for my object info and then put that into my geometry there. You'll notice that it's way too big. So let's click on that weight. I'll turn back on my viewport overlays. In the 3D viewport, I'll hit Tab to go into edit mode, and then I'll hit S to scale that cube down just a bit. And so one thing that I can do here is I don't actually need this extra transformation in order to get this object into the correct place, because I can do the transformation in the actual weight object. So if I go back into edit mode using Tab, I press A to select all. If it's not already selected, I can do Alt A to deselect all, and then hit X to delete that. I'm going to Shift A and add in some cube geometry again so that it's the default size. And I'm going to move this up so that the origin is right at the bottom of the cube. So I'll do that by G for translate, Z for along the Z axis, and then I can just type in 1 and it'll move the geometry that I have selected up along the Z axis by a value of 1. And then what I can do is just scale that down, and I want to scale it around that bottom point. And so what I can do is I can hit and hold period on the keyboard, and this will bring up a pie menu which determines what reference point we'll use for the origin of transformations. So basically the point about which you'll scale. So by default, that's the median point, and that'll be the center of all the vertexes of this cube. So I'll hit 3D cursor, because my 3D cursor is at the origin, and then hit S, and just make that a size that I think is good. Now you'll see that this cube is shaded smooth, so it's got some odd shading in the viewport. We can fix that by adding a bevel modifier like we had before. Bring that bevel amount down, adding in some more segments. We'll definitely want to put on auto smooth and then harden normals. And one more issue that we're having is that the rotation of our weight object is not correct. But we can set that in our geometry nodes editor by deleting some of the old nodes that we no longer need, because we don't need this transform node anymore. And then we'll want to rotate this object in the direction of the position of the end of the curve sampled at a factor of 1. So add in vector math normalize to get that vector with a length of 1. And then we're going to use a align Euler to vector node to align the z direction of this cube object to this direction. So if we do that and pipe it into rotation, then it will align, but it's aligning in the opposite direction. So what we want to do is actually scale this normalized vector by -1, and now your weight object will be aligned. Now you probably don't want to use a cube for this, because as it rotates it will intersect with the track. So if you're going to do that, then you might want to actually move that pendulum up a bit, and then you'd have to change the length of the handle. But another thing that you can do is just add something like a cone. So I'll GZ to translate along the z-axis -1, and then since my rotation origin point, or my transformation origin point, is already on the 3D cursor, I can just hit R to rotate from my current view, and then type in 180 to rotate 180 degrees, and then S to scale that down. And now we have the weight as this cone, which just sort of like draws the edge of the track with its point. I'll do a bit more modeling on this to make it render ready. And I'm actually going to do the bevels within edit mode. So I'm going to delete this bevel modifier. I'll use tab to go into edit mode. I'll hit 3 on my keyboard to go into face select mode. I'll left click to select this top face, and then do Control B to bevel. And I'll just bevel out. Maybe let's make this like almost like a diamond type shape. So I'll bevel out about that far. And then I'll select the new top face, and I'll bevel that to get a nice edge. And I'll click into the bevel operator, pop up, and up the segments to something like 6 is probably good. I'll do the same for this edge loop going around the edge. So what I'll have to do is switch to edge select mode by hitting 2 on the keyboard. And then I'll shift Alt, and I'll click in the center of one of these edges moving horizontally, or oriented in the horizontal direction. And that'll select that entire edge loop. And I'll Control B again to do a bevel. And I'll keep the same settings as before. In object mode, if you tab in object mode, you'll go into edit mode, and if you tab in edit mode, you go to object mode. I'll right click with the weight selected, and I'll hit shade smooth, and you'll see that it all looks fine except for coming down to this point here. It looks a bit odd, and we can fix that by adding a bevel to the vertex right at the point, so it's not all of this geometry just all converging on this single point. So I'll switch to vertex selection mode using 1 on the keyboard. I'll click to select that vertex. I'll hit Control B. I'll left click. And then I want to set the effect selection to vertices, and then the width to something a little higher. I'll actually change the segments just down to 1. So I'll just change it just a bit, and then I'll click out to confirm. And then I want to bevel this one more time, kind of like I did the other edge loop. So I'll hit 2 to go back into edge selection mode, Shift Alt click to select this edge loop, or I could go to 3 face selection mode and just click on the face, Control B, and then drag out. I'm holding Shift to make the change in the bevel weight value slower. If you let go of Shift, it'll go a lot faster. But if you hold Shift, it'll go slower. Click to confirm. Change the segments to something a bit higher. And there you go. Looking pretty good. And so you can go really crazy with this and make whatever weight shape that you want. I'm going to add in a couple of rings around the base. That's Control R to add edge loops. I use the scroll wheel on my mouse to add multiple cuts. We're just going to use 2 cuts. I'll confirm that. I'll press 2 to go into edge selection mode, and then Shift Alt left click to select an edge. And then I'll hit G and then G again to slide that edge. And I'll just move that right up here. I'll do a similar thing for the top. And then I want to select this entire face loop here. So what I'll do is I'll hit 3 to select face selection mode. And then Shift Alt, and I'll just click on one of the edges in that face loop. Get that entire face loop all around. And then I'm going to hit E to extrude. And then I'm going to right click just to cancel because I don't want to use the default extrusion transformation. Instead, I'm going to do my own transformation in just a second. And then I just want to scale all of my selected faces inwards. So if I hit scale, it'll go down to the origin. But I don't want to, I want to scale around the x-axis and the y-axis, but not the z-axis. So what I do is I hit Shift-Z to exclude the z-axis, and then I just scale right in like that. Make that little divot, and I need to add bevels here as well. So I'll switch back to, actually I'll go into face mode. I'll select this face loop with Shift-Alt left click. Control B, that actually doesn't work. So Control Z that, go into edge selection mode, and then select all of the edges with Shift Alt left click that you want to bevel. Control B to bevel. Move those out just a little bit. I want those nice sharp edges. And there you have it. There's a weight object that I'll use. But you can replace this with whatever you want. It's kind of fun. So I'm going to hide this original weight object in both the viewport and the render. I'll press 0 on my numpad to go back to my camera view. And now you can see my new weight moving on the pendulum. And you can see that this weight shape sort of accentuates the fake chromatic aberration shader a little bit more. And I might actually want to change that to be a little more subtle. Or actually what I'll do is I'm going to change the roughness values for all of these. So I'll add in a new value node with Shift D to duplicate this value node. I'll pipe it into all of these roughness values, and then I'll bring that up to something like 0.1, maybe 0.2, maybe 0.15, 125. There. I like that. One other thing that I just noticed that's bothering me a bit is the hard shadow that you're seeing from the original sun that I made. And we're going to fix that just by upping the angle for that sun to something a lot higher. I'm shift middle clicking to pan in the view here. And now we're ready to render. So we'll just want to make sure that our render settings are what we need. We'd set the resolution to 1920 by 1920 pixels before, which is great. I'm actually going to change the frame rate to 30 frames per second. It'll move a bit faster, but it'll be a bit smoother. And then in our render tab, we'll use cycles as we said before. GPU or CPU. CPU just take a bit longer. I'll set the samples to 512 with the denoise set to open image denoise, albedo and normal pass, pre-filter set to accurate. So if we do a little test render with render image, we can see how long it takes. The open image denoise takes a little bit of time, but it is worth it, especially on scenes like this with a glass shader. It does well with those. I can kind of see a little bit of the facets of the track object, and we can fix that with a little bit of changes to the geometry. So you can see how there's just like one line across each section. We're going to want a couple lines running through the middle. So we can go to the track object into the geometry node editor, make sure to select and highlight the geometry node modifier that you want in this modifier tab. And then what we'll do is we'll just resample the curve line that is the profile curve for the curve to mesh node. So resample that curve. Doesn't need to be 10, maybe 4, maybe 5 or 6, just 5. 5 looks good. So now when we render that, you don't see those subtle lines moving across. If we really want to be safe, let's set it to 8. Actually, let's set it back to 5, and then let's just add a subdivision surface modifier to the track. Probably doesn't need to be value of 2, but 2's fine. So now if I turn off optimal display, you'll see that this is the ultimate geometry for the track. Let's do another test render. And that is looking the way I want it to look. Cool. So just make sure in your output properties that you set a destination that's not the temp file. These default settings of PNGs are fine. You can set it to JPEG if you want. If you want to do high resolution, that's a whole other story that we won't cover here. And when you want to render out the whole animation, just do render animation and it'll get going. Render out each frame, and then maybe in another tutorial I'll cover how to convert the frames into an actual video, because you want to render out to individual image frames rather than directly into a video, because if the render fails for whatever reason, your computer crashes or something like that, then you've lost all of the work that you've already done. So it's a much better solution just to render out all the individual frames, and then you can just use Blender, the video sequencer in Blender, to bring in all those frames as a frame sequence and then render that out to a video in the end. One more detail that I wanted to add is that if you want to change the length of your pendulum arm, you can go into the Pendulum geometry node network, and then right here where you create the pendulum arm mesh from the curve, you can just Shift A and add in a trim curve node and just change the end a bit. And you can see here that with this geometry you see the end of the arm poking out just a bit, so you can just move that a bit in, or you can move that all the way to the top if you want, or just edit the length of it based off of whatever weight geometry or weight object you end up creating. But I'm just going to set mine so that it goes pretty much all the way through but doesn't poke out the end, because I didn't think that looked the best in the render. And this is the last edit, I promise. But one thing you want to make sure to do is in your track geometry node network, you have to set the curve normal for the guide geometry to Z up before you use the curve to mesh node. And if you don't, then you'll get this slight wiggle in your curve during the animation. So just make sure to set that, and your curve will remain smooth and flat throughout the entire loop. So that is it. Hopefully you have learned how to create an infinite looping pendulum animation in Blender, and you can use this knowledge as a base to create your own satisfying motion graphics animations. If you are new to Blender, keep at it. It's tough, but it's great, and you'll learn a lot. There's a deep rabbit hole to go down. I highly recommend it. So anyway, I hope you enjoyed this tutorial. I hope you learned something. I hope you had fun. And until next time, bye.